All right, today we're simplifying square roots involving variables. So when I'm given something like x squared, let's say I'm given an equation like x squared equals x, right?
No, on the board.
Okay. Okay, say I'm given an equation like x squared equals x. If x is 3, when I substitute in, does this make sense?
Yeah.
And it's a true statement, right? Yeah. But let's say in that same equation, if x was negative 3, if I substitute it in, is this a true statement?
No.
Notice I'm simplifying each side. Okay, I don't have time for fooling around, so just stop. So, because of the negative, it doesn't work, right? So we have a special situation. So what we can do to account for that negative is it only works when you have non-negative values. So what we do is we take the absolute, we make the statement that square root of x squared equals the absolute value of x. That will handle your negative. Now, if I substitute a negative in, right? Now, it makes a true statement. Are you clear on that? Sure. You don't have to write this part down. Don't worry about writing. The next page, you're going to write everything down. Yeah.
What if there's a negative outside of the
Don't worry about it. Let's worry about understanding this, not in the what ifs. Because we're going to have 26 slides worth of what ifs. Okay? Shh. Oh, sorry. Okay, so I'm recording. All right, here. So just understand it. Look at the board right now and just understand what I'm saying. Do you understand what I'm saying? If I use that absolute value, when I substitute a negative 3 in there, it's going to work because when negative 3 is squared, it's 9, and the absolute value of negative 3 is 3. And when I take the square root of 9, it equals 3, so 3 equals 3. You guys with me? So now let's follow the pattern. We said that when we take the absolute, when we're looking at the square root of x squared is the absolute value of x. That way, if it's a negative, a positive, it doesn't matter, but if it's a negative, it's going to work. Because it can't have a number in there, take a square root, and if I put a negative number in, it won't work. Do you understand? So this is just in case we have to account for negatives. So this page you are following. So now let's look at x to the third. When you have a radical like this, I want you to go to the closest even exponent, which would be x to the second. Break this down to x to the second times x, right when I'm writing. Now, do we know what the root of x to the second is? It's x. And then we can't take the square root of x because it's not a perfect square, so I leave it in there. Okay? You guys with me? Did you write all that? Now, I want you writing these steps. I'm going to erase them so I can get to the next part. But I want you writing these steps when you're doing your homework. I don't want you doing mental math when you get this. Okay, so let's go to x to the fourth. So now, x to the fourth, what's the square root of that? X squared. No problems, because if it's negative, a negative times a negative is a positive, right? So in this equation, if x is negative, it's not going to be an issue. Let's go to x to the fifth. I have an odd amount, so I'm going to break it down to the closest perfect square. X to the fourth, the closest even times the square root of x. What's the root of x to the fourth? And then I'm left with radical x. You guys with me? You're writing it. Both steps. Okay, can I move on?
Yes.
Okay. So when I have x to the sixth, what do I do? Chris?
Find our closest, nearest, even.
It is even. So we can take the root of it. When it's odd, we can't take the root. So what is it? What's the root of x to the sixth?
X to the third.
Yep, x to the third. But if it's x to the third, what happens if it's negative?
It won't work.
It won't work in a radical. So what do I do when I have an odd result like that? Yes.
You put absolute value.
Right. So the rule is, can anybody tell me when we use the absolute value?
When it's odd.
Daniel?
When it's odd, which means that it won't work because the negative will stay.
But this is odd. So
When
you're
it's
odd and
it has the radical. When it
an odd and all alone. When the result is an odd result and it's all alone. Because let's say this is a negative and this is a negative. When you multiply them together, it'll make a positive.
Okay.
So it's not enough to just be an odd result. It's an odd result all alone. Okay. Next. Okay, so x to the seventh. What do I do? X to the seventh, what do we do? Who is that? Okay, Spencer. We first times the square root of, and the answer is? X to the what? No, just what is the answer? What does that simplify? Times x to the third times, and you can say rad x. It's less of a mouthful. X cubed rad x. X cubed times rad x. Okay? You guys understanding? Yes or no? Thumbs up yes, thumbs down no. Okay, let's try the next one. X to the eighth. Try it. You guys go. Okay, Cubby, what did you get? Well, what do you have? What is it? It doesn't take a lot. It's easy. It's even. X to the fourth. Okay? Okay. Now, this one takes work because it's odd. So I have to break it down to the closest even, x to the eighth times an x. Now, what's the answer here? How about Adam?
X to the fourth rad x.
Perfect. You guys good? You getting the pattern? Next, x to the 10th. Jordan.
X to the fifth, yeah.
Close.
Absolute value.
The absolute value of x to the 5th. Next one, x to the 11th. Daniela.
X to the sixth.
Nope. X to the, got to go to the closest even.
To the 10th. X.
Good. The root of x to the 10th?
Absolute value of x to the fifth.
No, we only when it's alone.
So x to the fifth.
Mm-hmm.
And then x.
Times rad x. When it's odd and it's not alone, don't worry about it. Only when it's alone do we use the absolute value. Because if this were negative and this were negative, it would end up being positive. Does that make sense, Ben?
Yeah.
So it's only when the odd result is all alone. Okay, next one. Why don't you finish x to the 12th and x to the 13th up? Pause the recording. Okay, Sophia, what is the next one?
X to the 6th.
And the one after that?
X to the 6th times the radical of x.
Okay, so we break it down to x to the 12th. I want this in-between step for homework. Do you understand me?
Yes.
So it's x to the 6th times rad x. Okay, that is my final answer, simplified. But I want to see that work. Yes?
For like perfect squares, like x to the 4th and x to the 9th, why is it not x to the 3rd? Because if
X to the 4th?
x to the 4th, x to the 4th, square rooted, why is it not x squared? And that, no, for x to the 9th, why is it not x squared?
X to the 4th? Why is it not x squared?
For x to the 9th, for x to the 9th, why is it not x?
Okay, shh. So, you missed the step. It's x to the 8th. Oops, sorry, that 8 should be inside. Here's the step that is not written there, that I was writing in pen. Times the square root of 8. The root of x to the 8th is x to the 4th. The root, x to the, that should be an x. The root of x, it's not a perfect square. There's not two of them. Only is a perfect square if there's two. So my final answer would be this. Okay? All right. So now let's try, you guys try the next group. Go. Pause the recording and you do the rest. X to the 14th. Absolute value of x to the 7th. Good. The absolute value of x to the 15th. Let's go with Pascu.
Well, I got x to the 7th times rad x.
Yep. Okay, next one, Anthony.
I got x to the 8th.
Good. Next one, go Alan.
X to the 8th, rad x.
Good. Next one, Ari.
X to the 9th, value.
Absolute value of x to the 9th. Next one, go Chris.
X to the 9th times rad x.
Good. Next one, go Ben.
X to the 10th.
Good. Next one, go, who is it? Sean.
X to the 10th rad x.
Good. Next one, go, Sophia.
Absolute value of x to the 9th.
Good. Next one, go McKenna.
X to the 11th times rad x.
Good. Next one, go Daniel.
X to the 12th.
Good. Next one, go Hike.
X to the 12th times rad x.
Good. More. Go. Pause it. Shh. All right. So x to the 50th. Let's go with Matthew.
Absolute value x to the 25th.
Oops. Absolute value of x to the 25th. Perfect. Good. It's an odd result. It's all alone. So it's x to the 25th. Next one, Sarkis.
Is x to the 21st.
X to the what?
21st.
21st?
Yeah.
Divided in 2.
The first is x over 42.
It's just x to the 42. That's it. You're taking 2 squares. Divide it in half, and that's the root. Okay? Now, Ben, this is going to require some work. So I do what?
X to the 51st.
No, go to the closest even.
X to the 50.
What's the closest even to?
X to the 100th power.
Good. Times.
X of rad x.
Good. And so what does it become?
X to the 50th.
Yep. Number 4. Required work, people. If you jump, you will get no credit. Okay, next, Shaylin. Number 4.
X to the 52nd rad x.
I need the step. Closest even. I'm sorry.
X.
I need to stop asking this question. Stop mental mathing. Go.
X to the 152nd
Okay.
rad x.
Good.
And X to the 52nd rad.
Oops. X to the 52nd. X to the 51st. Rad x. Okay, next one. Sophia.
I have a question. If it's like 103, do you round down or do you go
You go to the, if it's an odd number, you go to the closest even down. Yes. So what would I do here, Sophia? Go to what?
You would go to x times
To the
252nd.
good times x. And the square root of that would be x to the
121st.
6. And times the square root of x. And then the last one, Molly?
It's just x to the 241st.
X to the 241st. You guys get the idea? Yes.
Oh, yeah.
Oh, because it's odd, we have to put it in absolute value because it's an odd result all alone. Okay, let's go next. Okay, so now talking about domain. Just like what we did before, but I do want to say this. On the test, I got people, when I asked for exclusions, they did stuff like this. Okay? This is, when you use this, it's a solution set, not for exclusions. The way we show exclusions is we show x does not equal. Now, this happens to be asking for the domain, so you can use solution set. Do you understand? It does ask for domain, so we're going to say x is an element of the reals. It wants to know all of what x is allowed to be. But x, what's the big golden rule for square roots? Anthony. It can't be negative. So what would I say? How do I say that in math symbols? Yeah.
X is greater than or equal to 0.
X is greater than or equal to 0. So x is an element of the reals, comma, and x is greater than or equal to 0. Because now we're in radicals. Before it was fractions, where you can't have a 0 in the denominator. In radicals, you can't have a negative in there. I can't take a square root of a negative. So I'm going to do the same thing here. X is an element of the reals. Then I take everything under the radical, and I set it, x plus 4 is greater than or equal to 0. That whole thing has to be 0 or greater. Subtract 4, and the other piece I'm adding is x is greater than or equal to negative 4. Okay, questions? So it can be a negative as long as it doesn't make the result a negative. Negative 4 and 4 make 0. Negative 3 and 4 make 1. Negative 2 and 4 make 2. 0 and 4, so it can be all of those. It can be positive 4. It can be positive 6. Questions? Okay, do the next one, please. Shh, pause the recording. All right, so what did you get? Let's go with somebody I haven't heard from. Who have I not heard from? Ben, have I heard from you?
No.
Okay, Jordan. Okay, go on. Jordan.
X is such that x is an element of the reals.
And
x is greater than or equal to 5.
Yep, that's exactly it. There you go. Questions? Yes.
What would you do if it was something like instead of
Hold on. I'm sorry. Go, Sav.
What would you do if instead of it being like the radical of x, it was like 5x?
Well, it would be, so she's asking, hold on, that's actually going to be our next question. She's asked something like, which isn't this kind of the same? The square root of 2x? Right? Is this what you're asking?
Yeah.
So, again, we're doing the same thing. We set under the radical has to be greater than or equal to 0. Because anything less than 0 is a negative. So I take what's under the radical and I set it greater than or equal to 0. Divide by 2, divide by 2. X is greater than or equal to 0. So it can be 0, it can be 1, it can be 2. Anything 0 or greater will make it a true statement. Does that make sense? Okay, so for that one, x is an element of the negative, of the negatives, is an element of the reals, and x must be greater than or equal to 0. Okay, next one. Why don't you guys try it? Pause the recording. All right. Okay, Anthony.
So you set it to be 5x minus 1 is greater than or equal to 0. You add 1 to both sides, and then you'll get 5x is greater than or equal to 1, and then you divide each side by 5, and you'll get x is greater than or equal to 1 over 5.
And we say x is an element of the reals, or x is greater than or equal to 1/5. We should say and. Questions? Okay, next. So, okay, very quickly, we're going to be, this is just getting us used to, we're going to be using equations like this. These are pieces and parts of our quadratic formula. So when it says evaluate, we just substitute in, right? So if b is 3, I substitute in for a b. Now, how do we do these kinds of problems? Notice it says 3 squared, right? It's 9. And notice right here, it's negative 4 times 2 times negative 2. A negative times a negative is a positive. And 4 times 2 is 8 times another 2 is 16. You with me? And that simplifies to 25. And so that would be 5. Try the next one. Pause the recording and go on to number 2. All right. So now let's go on to this. When I'm taking, when I take the square root of n to the second power, I get x to the first power in the absolute value. Because it's an odd result, we must put it in absolute value. Same thing goes if we have a binomial. When we have a binomial, it's to the second power. When I take the root, it becomes to the first power. Since it's an odd result for that binomial, then as in to the first power, I have to put it in absolute value. Are you guys clear on that? So let's look at when I take the square root of x minus 4, what is the answer? Yes.
X minus 4 in absolute value.
Absolute value of x minus 4. What would number 2 be, please? Yes.
Absolute value of 2x plus 3.
Good. What would number 3 be, please? Bella.
Number 3 would be y minus 5.
Look at the others. Y minus 5 what?
Absolute value.
Yes, correct. Okay, now number 4, you have to factor. Number 4, you have to factor. So what does that factor to, McKenna?
It factors to x minus 3 times x minus 3.
X minus 3 squared.
And then it would be the absolute value of x minus 3.
Okay, bottom one. Why don't you guys all do it? Go. Molly.
The absolute value of n plus 5.
Okay, so when we factor it, first of all, we're getting, I want to see the 3 steps. M plus 5 is the first step. And then when I simplify that, I get the absolute value of m plus 5. Are there any questions? Okay. Now, you think they're going to have any kind of factoring other than perfect square trinomials?
Yeah.
Not necessarily, because you won't be able to do anything with it. Not under the radical to get the expression. Not in this section. All right, so now we're going to learn. We have 4 minutes. We learned to solve before using, and I want you to write down what I'm writing down. We learned to solve last time a quadratic setting it equal to 0. Well, now we're going to use a property of equality and we're going to use the square root method. So what I'm going to do is, when I see a square, I'm going to say, don't be rude, just root it. Square root property of equality to both sides. When I take the square root of x squared, we get what? What? No, we don't get x. We get,
The value of x.
yes, we get the absolute value of x, which equals, and the square root of 9 is 3. To lose the absolute value, we write x equals plus or minus 3. Remember before, when it's an odd amount, we get the absolute value, right? So when I go from here to here, this is this simplified. And to lose the absolute value, in order to make it just x, because I got to isolate it, it means I can have x can be positive or negative. So I have to account for that here.
Okay, so would you want us to keep it a negative 2, or is it just a principle?
No, not the principal here. When you're solving, we are not doing just the principal. There are 2 roots that can possibly, because remember, it's not like you're starting here. You're starting with this. And in that situation, you can have 2 solutions. Okay? I'm using the square root property, but I can have 2 solutions from what I started with. Yes, quickly, hurry up.
So, how would you write the answer?
Just like this. Okay? Now, they're just going to get same thing. Don't be rude, just root it. Root both sides. What would the next line read? Everybody?
Absolute value of x equals 6.
Good. Next line. If you leave this as your answer, it's wrong. If you leave this as your answer. Okay? I'm going to go on since we have more to. Okay. Let's do the next one together. Please write it. What am I doing?
Absolute value.
Not yet. You have to do both parts. And then I get root both sides. I get y equals, the absolute value of y equals square root of 7. Let's finish this. Leave it under the radical. If it's not a perfect square, it's much more accurate this way. Mathematicians very rarely estimate the way we did yesterday. So now, to lose the absolute value, I get y equals plus or minus the square root of 7. How would I do the next one? Add 6, add 6. I'm recording. M squared equals 13. Take the square root. Absolute value of m equals the square root of 13. M equals plus, I'm not done, plus or minus rad 13. Do not shut your journal. Pencil should be in hand. Questions? Keep going. Shh. Okay, now let's look at, okay, subtract, divide. Do you see what I'm doing? Get the quadratic all alone. Then root it. Don't keep shutting your book until I tell you to shut it. So you're going to get the quadratic all alone. That's the point that we root both sides and set it equal to plus or minus. Okay, next one. Keep going. Okay, doing the same thing. Divide. Now what? Okay, I'm rooting. Oh my God, I just did something illegal against the law. Oh my gosh, I should say, not oh my. Okay, so I get the absolute value is equal to the square root of negative 7. Really? You can't have a negative in there. So you say, shh, no solution. In this case, it's an equation. Do you understand? Stop it. It's an equation, so we'd say no solution. Okay, couple more. Now what? Now what? We root both sides. So what do we get?
Y plus 1 equals
Absolute value of y plus 1.
equals 4.
To lose it, I do y plus 1 equals plus or minus 4. Subtract 1. Y equals negative 1 plus or minus 4. Branch it out. Negative 1 plus 4, negative 1 minus 4. That's that's positive 3. And this is negative 5. So y equals Questions? You got that? I think that's the last one. That's the recording.